Hello, it's me again. Today, I'm going to be going over how to make a door in Unreal, mostly in C++. I tried to make this video short, so some parts where I write code might be fast. So if you're going along with me, feel free to pause the video. I figured this would be better since in my own personal experience, just seeing someone write code any slower doesn't help. Instead, I divided the video into sections and decided to explain chunks of code visually. The first will be simply making a door actor. The second will be making the door interactable through the character, and the third will be implementing a one-sided door. Now the last part, which is optional, is just upgrading that to a two-sided door. Alright, just before we get in, I just wanted to explain to you what I have to start. I just have a simple first-person movement with WSD and my mouse to rotate the camera. You could probably use anything though, even a third-person template, as long as you have a moving character and a camera. And don't worry, I'll try to point out the differences that you could make to adjust to your code later on. Just one thing to note, I'm going to be referring to this class which I name main character, which inherits the character class, as the character class. You might have code similar to this, but the name will probably be different. So I'll try to refer this generally as the character class, but remember to use whatever name you named it in your actual code. Alright, so moving on to our first section. I'm going to start off by creating a C++ actor. You can name it whatever you want, but for the sake of this video, I'm going to be naming it door actor. By the way, if you're making your game with an interactable interface, or if you want your door to inherit off of something else, that totally works too. For this video, I'm just going to keep everything simple. Anyway, in the door actor, I'm going to start off by creating two pointers to use static mesh components, one called door frame and another called door. Make sure to forward declare the one that comes first so we don't have to include its library file here. I'm going to give it a U property of visible anywhere and a category of mesh. Now we can go on to the constructor and create the two meshes with create default subobject. Just for convenience, I set up each of its name to its variable name. I also set up each of its attachments. I attached the door frame to the root component and the door to the door frame. Alright, now we can compile this. Once it has compiled, we can create a blueprint based off the door actor and name it something like bp/door. Again, name it whatever you like. Now we can open the blueprint up and select its static meshes. If you need to do some adjusting, feel free to do so now as well. I'm just using a door from a free asset pack by Epic Games called Edit Finch Edie Room, but I'm assuming you're here to implement your own door, so you can just use whatever door frame and door asset you have. Once you have selected your assets, we can try bringing that out into the world just to see how it looks. We still don't have any functionality on our door though, so we can't do anything, but that brings us into our next section. Alright, let's let our character interact with the door now. Let's first begin by going into the settings, project settings, engine input, and add an action mapping called interact. And I'm going to bind this one to my E key. Alright, now we can go back to our door actor header file and declare a function called onInteract. This function is going to be a function we're going to be calling from our character class. Basically, our character class will figure out if we are interacting with the door or not. And if we are, we will call this function, which will be responsible for the door opening or closing later on. So I just gone ahead and created the definition for the function in the C++ file here, and for now we can just add a simple ulog to later see if it's properly working or not. Now we can go into our character file, or whatever file you have which binds your action keys, and we can bind the interaction key we created in the project settings previously. Just a note though, I suggest you do this in whatever file that has access to your main camera. I'm going to choose IE press for my enum, so my character interacts on button press. Now we can also go ahead and create the calling function right now, which I'll name mine interact. I'll also give it a definition and input the address of the function into the bind action function. Alright, now we can implement the interact function. I'm going to start off by checking if the camera is a null pointer or not, and early returning if that's the case. By the way, be careful if you named your camera something else, for example, follow camera. Next, we're going to want to do a line trace, so I'm going to first do some setup for that. For the line trace, we can take the camera as our starting point and the camera forward vector multiplied by a length added to its location for its endpoint. For the length here, we can either choose to hardcode a value or do something better and create a variable for it so we can configure it later on. I'm going to call this interactive line trace length and give it a U property of edit anywhere and a default value of 350.f. But this is totally up to you. Now we can go on ahead and get the world and operate a line trace single by channel, inputting our hit result, start, end, and choose our collision channel as ECC visibility. By the way, if you're a bit confused on what's happening, here's a quick visualization. For f vector start, that is just the camera's location. For f vector end, we're taking the camera's forward vector, and remember, vectors don't have locations, so I'm just going to draw it here. Then multiply this vector by the length, and now add this vector to start. Whatever we have left over here is f vector end. Now that we have 2 points, by drawing a line between these 2 points, this is basically what line trace single by channel is doing in a nutshell. It shoots a laser and detects whatever it hits that has its collision channel visibility set to block. By the way, you can check any object's collision setting by checking its blueprint. For example, for the door, I can select one of the meshes and scroll down to find collision preset, and open up the tab to see that visibility is set to block. Alright, here's a quick summary for line trace single by channel. If we have a door, the door blocks the line trace because it blocks the visibility collision channel which we performed the line trace on. Then all the related information about this is now stored into the hit result struct. Now one of the functions this struct contains is called getActor, which returns the actor that is hit. Now with all this information in mind, we can go back to the C++ file and finish up our interact function. I'm going to start by pulling out the getActor function from the hit result struct. Now unfortunately, just with this, we don't know if we really hit a door or not. So I'm going to try casting this into a door actor to confirm indeed that this is a door. Now I am using the door actor, so I'll have to include the door actor heading at the top here, but if you named your class something else, your include would be thatname.h. Alright, I'm just going to save the door actor I casted here into a pointer called door. And finally, what's left is just checking if the door exists, and if it does exist, we can call onInteract. And sorry, I just realized I misspelled door here. Anyway, now we can compile and save and see how it works. And as you can see, when I press E, I'm getting a message in the output log that we've created earlier, so we know that interaction is working. Now, one thing we could do to visualize the line trace is add debug lines such as like the code here under our line trace. If you do so, just make sure you add the include of drawDebugHelpers.h at the top. Another thing we can do is change the ulog message in our onInteract function from display to warning. Now if we compile that, we'll end up with a visible line with endpoints in our world. Alright, on to section 3. It's time for us to implement the door. We can begin by first adding the include to timeline component in our door actor header file. If you don't know what a timeline is, it's basically just a timeline that has a lot of keyframes that each trigger an event. In our case, that event is going to be calling a function that does the opening of the door. Basically what we're going to be doing is when our character interacts with the door, it plays a timeline and the timeline is going to help us animate the door opening. So right now, I'm just calling all the necessary variables and then later the callback function which will open the door. B is door closed is just a boolean that determines whether the door is open or not, so we can put it at true for now since the door starts closed. Just a note, if you have many doors and have some open at the start, you might want to give them the U property of edit anywhere, so you can change some of them to false later on in the blueprint. The door rotate angle float is just the angle we want the door open up to. I'll make mine 90 degrees, but again, the number is totally up to you. Now we can finish up by creating our callback function called openDoor. And by the way, make sure this is a U function. Alright, now we can go into the door actor CPP file and start adding some implementations. I'm going to begin by making sure curve float exists, and rather than explaining to you what it is, we could just create one right now. In Unreal, we can click anywhere in our content file and go to miscellaneous and select curve. Then select float curve and you can name this whatever you want. Once we open that up, we're given a thing that kinda looks like a graph. Now start by going to the middle and right click and select add key. Right click again to add a second key. Once that's done, change one of the keys to 0, 0 and the other to 0.5 and 1. You'll end up with a linear line like this. Now right click both the ends and choose the auto setting for both. You'll end up with a curve like this. This is what our curve float is. We're basically going to map this curve from 0 to 1 on the value axis to the door angle. As a result, we're going to get the door opening smoothly. Alright, back to our door actor CPP file, we can now finish up our timeline. I'm going to first declare a f_on_timeline float called timeline progress, then bind a function to it using bind dynamic. The function we're going to be binding is open door, so we can quickly make that right now. Now we can add interp float from timeline with the arguments curve float and timeline progress. Basically what this is doing is interpolating the progression through the timeline to a smooth curve we made earlier. To keep the timeline ticking, we can add tick timeline to timeline with delta time in the tick function. Now we can go and implement our open door function. The argument value here comes from the value you saw earlier in the curve float graph. And if you remember, the value ranges from 0 to 1, so we can multiply that by the door's rotate angle to create a rotator where its yaw ranges from 0 to 90 degrees. So now we can just use this rotator and set the door mesh's relative rotation as it. Alright, all we have left to do now is actually start the timeline we just created. We can do this from the onInteract function. Timeline.play just plays the timeline forwardly, and timeline.reverse just plays the timeline in reverse. We can select which we want to do using an if and else statement with B is door closed as its condition. So just open the door if it's closed and close if it's open. And one thing we want to make sure to do is flip the boolean after we're finished with it. Now we can compile and save and test it out. And as you can see, we got ourselves a nice one-sided door. And I say one-sided because the door opens the same way no matter where you are. So in order to fix this brings us to our next section. Our last section, we're going to be upgrading this door into a two-sided door. Alright, back in the door actor header file, we're going to need a way to obtain the character class. There are other ways to do this, for example using gameplay statics, but I'm just going to simply create a public pointer to my character class here. And then in my character class CPP file interact function, just before we call the onInteract function through door, I'm going to also make the character equal this, which is just my character class. Alright, now that we got a pointer to our character, back in the door actor, I'm going to declare two more things. One is a boolean called bDoorOnSameSide, and then a function that's going to be setting that boolean. In our CPP file, let's start by implementing this function. Here, we want to figure out if our character is on the same side as the door actor's forward vector. So I'm going to start by checking if the character exists. And if it does exist, I'm going to get the character's forward vector, as well as the forward vector for the door actor. After getting the two actors' forward vectors, to figure out if the door is on the same side or not, we can actually perform a dot product operation and do an equality if it's greater or equal to 0. If you don't really get this right now, don't worry, I'll try to explain more of this bit later. And if you're using your own character class like me, you're going to have to do an include at the top. Now we can call this function just before we open the door since we want to open and close the door to its set side. And now, the very last thing to do is just set the angle of rotation accordingly. A negative rotation if the character is on the same side, and positive if the character isn't. This line of code here, by the way, is just a ternary operator. You can also use an if statement if you would like. Also be sure to change the door rotate angle to this angle. And now we can compile and save for the last time, and we got ourselves a two-sided door. One thing though, if you find it a bit annoying that you have to click directly on the door to open it up every time, you can go to its blueprint and create a box collision while setting up its dimension to fit the door. Remember to also set the collision settings by first selecting the collision preset to custom. Then we can change everything to ignore except for visibility, which is to block. And now we can compile and save the blueprint, and now we can open the door from the middle. Alright, I promised to explain to you what the last bit of code was doing, so I'll finish up the video with that. So I'm on this website called Geogebra, which I'll put the link in the description. U and V here are both vectors. One of the neat thing about dot product is that as long as the two vectors are within 90 degrees of each other, the result becomes positive, and if the two angles are above 90 degrees, the result becomes negative. You can see the result of these two vectors and their dot products on the top right corner here. Now using this, we can actually find whether we should open a door 90 degrees or negative 90 degrees. Here's what I mean. Let's first start by filling this table I made here. Dot is the sign of the result of the dot product, positive or negative. bDoorOnSameSide is the boolean we set, and the angle is the angle we get from the ternary operator in the open door function. Now, if the dot is positive, that means it's greater than 0, so the boolean is set to true. If the boolean is set to true, then the angle becomes negative 90. On the other hand, if the dot is negative, then that means it's less than 0, so the boolean is set to false, and then the angle becomes 90. So with all of this, let's do a quick demonstration. I have door shown here from the top view, and let's say the forward vector is on to the right. Then the rotation will be negative 90 degrees this way and positive 90 the other way, assuming the pivot point is here. Now let's say your character is also located here. Now for a character to open the door, it has to look at the door, and let's say the forward vector becomes like this. Then the angle between the two vectors are now obviously less than 90 degrees, so the dot product will be a positive number. This means the angle for the door to rotate will be negative 90, and thus the door will open outwardly as we expected. We can also try another instance just to make sure this really works. Let's say your character is here, then the forward vector would be something like this, which is more than 90 degrees from the door's vector. So the dot product being a negative value would give the angle to be positive 90, opening the door outwardly again. Great, it works! You can always try the other possibilities yourself and see how it works. Anyway, that's all I have for this video. I hope I helped even a bit. And as always, thank you for watching and have a fantastic day.